Welcome to New South Wales DPI's first webinar. In this first webinar, we will be talking about automatic milking systems that are also known as AMS or robotic milking systems. This first webinar will be delivered by myself. My name is Nicolas Lyons. I am the Development Officer for Robotic Milking Systems. So I would like to make a small introduction of myself before we start. I'm originally from Argentina. I did a Bachelor of Agricultural Science back there. And in 2010, I decided to come to Australia to enroll as a PhD student at Sydney University within the Future Dairy team. There I conducted research during 3 years, researching the integration of automatic milking systems in grazing environments or grazing systems. I finished in 2013. And after that, I've got this position as the Development Officer for Robotic Milking Systems. This is a national role that has the aim of supporting technology adoption within the Australian dairy industry with a particular focus on robotic milking systems. So a lot of my work revolves around providing good information to farmers and service providers in order to take the best decision that will hopefully support a profitable and sustainable integration of technologies onto the dairy farms. And I engage a lot with farmers and service providers and researchers and commercial companies to be able to understand what is needed or what are the barriers for adoption for technology and specifically robotic milking in Australia. So all in all, I've got over 10 years of experience in both public and private organizations related to the dairy industry. And I've always had direct contact with farmers and a whole range of key players within the industry, such as researchers, vets, agronomists, consultants, and milk processors, because always my main responsibility have been involved with understanding and analyzing current on-farm industry situations and be able to deliver, develop, and monitor effective strategies to transfer the best knowledge and management practices to the wider industry. So now going to the topic that is around the webinar today. The agenda for today is a bit what is displayed in the current slide. We will first cover a bit of the challenges of the Australian dairy industry. Then we will look at AMS as an option for farmers and the key concepts involved around it. Then we will analyze what can and what can't AMS do. Then I will give you a brief overview of the adoption in Australia to date. Then what is achievable under AMS under commercial conditions, and we will wrap up with some conclusions. As I said, I will aim to try to go over all this in 30 minutes. That's my aim at least. So to start with, I would like to give you a bit of an overview of the Australian dairy industry and the labor situation. 98% of Australian dairy farms are family owned. So there are families running the business. Around 50% of Australian dairy farmers have over 15 years old, are over 15 years old. So it is an aging population running these farms. Around 35% of farmers do not employ any external labor, so they rely on themselves and their families to be able to run the whole business. And when we analyze business performance, labor accounts for around 20% of the operating costs. So after feed, labor is the second largest cost in the operating costs in a dairy farm. So labor has a huge impact in running the dairy business. When we analyze the dairy industry, we see that there's every time less farm, but farms are larger. So if we look at the situation in 1980, there were around 22,000 farms and an average of 85 cows per farm. If we go forward to last year, we had around 6,000 farms with an average of 250 to 160 cows per farm. So there's less farms, but those farms are larger. Then the working conditions of the dairy farms are sometimes against the lifestyle because they involve early starts and late finishes in an environment that involves harsh weather, rain, mud. So it is the working conditions around the dairy industry are harsh for people that are outside in the industry and people even within the industry. It is a time-consuming activity, so milking involves somewhere between 40 to 60% of the daily activities on farm. And I conducted a survey earlier this year, and around 56% of the dairy farms surveyed reported that they spend more than 4 hours per day milking, and 17% of them reported that they spend more than 6 hours milking. So milking involves a huge amount of time in the dairy operation. Coupled with the working conditions are the sheds in which we currently milk our cows. From that survey that I told you that I did earlier this year, 48% of dairy sheds responded that they were commissioned more than 15 years ago. So it's sheds that were built for smaller herds and to milk for less amount of time. And now we are milking larger herds and we are spending more time milking. Then dairying is not perceived as an attractive industry, and farmers mentioned that labor is a great challenge because of the difficulty to attract and retain staff to work on their dairy farms. This is probably been identified in the National Dairy Farmer Survey conducted by Dairy Australia as one of the biggest challenges for growth in the future, the possibility to attract and retain staff to work on dairy farms. So the industry is actively looking for different solutions to be able to address the challenges associated with labor. And they've relied on technology in different aspects to be able to address these issues in the industry. So we've gone from traditional walk-through parlors to herringbones, to larger herringbones, to rotaries, to larger rotaries, to be able to milk larger herds quicker. Then we've relied on different technologies like automatic cup removers, milk meters, herd management softwares, electronic cow ID, and different technologies to monitor different things in the herd or on the farm system, either pasture or animals, to be able to make the farming routine and the farming operation more sustainable as we walk into the future. So the big question that pertains to this specific webinar is, do robots have a place in the industry, in the dairy industry in general, and the Australian dairy industry in particular? And I definitely think that robots have a role and a place in the Australian dairy industry. Robots are not new, so to give a bit of history of when did robots start, the first commercial farm to install robots was in 1992 in the Netherlands, and that farm is still running and operating. So robots have been around for a very long time. So for over 20 years, robots have been milking cows. Today, it is estimated that around 15,000 farms are operating with robots worldwide. So they were traditionally installed in European countries with small herds, family-owned, high-yielding cows, and today they've spread all around Europe and to countries like Australia, New Zealand, South America has them, US, Canada, Mexico, China, Japan. So robots have basically spread worldwide, and all the indications are that they will continue to expand and adoption will continue to increase as we move into the future. So what are the key concepts around AMS and what does AMS involve? I can classify the key concept of AMS into 3 criteria. The first one is that they are automatic. The second one is that they are voluntary. And the third one is that they are distributed. So I'll try to explain now in detail what each of those key concepts involve. So automatic means that the robot performs all the milking related tasks. Human labor is removed from all the milking related tasks. And that is something very important. It only replaces labor in the milking related tasks. So what can a robot do? Every AMS available in the market today can identify cows, can clean teats, that is by washing and drying, and different brands do it in a different way. Some do it using rollers like the one in the image in the current slide. So some use a cleaning cup, some use the same milking cup that has a cleaning device contained within. So different brands do it in different ways, but all of them are able to clean teats and prepare them for milking. All the robots also attach the cups and are able to monitor milk yield and certain parameters in the milk while the cow is getting milk. All of the robots too are able to milk each quarter individually. So we do not milk with a whole cluster where all the milk goes together. We are able to monitor and measure yield per quarter and at a quarter level. What is the great benefit of that is that if one quarter has a higher, for example, conductivity that could be an indicator for mastitis, we are able to isolate that quarter and identify that that quarter in particular is having a problem. The other great benefit is that if one quarter finishes milking, we can remove that cup from that particular quarter where we continue milking the other 3 teats. All the robots are also capable of spraying the teats after the milking is finished and are able to release the cow and are able to use smart gates or selection gates to be able to direct cows to different parts of the farm according to where do they have to go. All the robots too have softwares available that the farmer uses to monitor everything that's happening in the operation. And that is very important because the farmer is not present at milking anymore. So he has to rely on data captured by the system that is captured and contained within reports and graphs to be able to indicate which cows need attention and how to better manage the whole herd health and herd production, but also the reproduction and the whole management of the farm per se. What can most AMS do? So most of the AMS that are available out there in the market are able to feed cows during milking, are able to send milk to different destinations. So for example, that is very important because if one cow has milk that has high, for example, conductivity and does not have to go to the tank, we can direct that milk towards somewhere else. Furthermore, if, for example, we have a colostrum cow or a hospital cow that is with antibiotics or has just calved and that milk cannot go into the vat, we can direct that milk of that particular cow somewhere else. So that provides a lot of flexibility into the system. Most of the systems are also able to wash themselves, so they're able to shut that particular robotic unit and conduct a whole wash or rinse in the system to be able to start again. So traditionally between 2 and 3 washes per day are conducted completely automatically. Most of the brands too are able to herd test every cow and every milking during a whole session to be able to extract a sample of milk, for example, to send to the labs or the herd testing centers for fat, protein, somatic cell count, or whatever. So most of the brands are able to do that. The second concept that I want to introduce is that cow traffic is voluntary. What does that mean? Is that traffic to and from the dairy occurs in a voluntary way based on incentives. So cows are not fetched from the paddock and brought to the robot, and are not taken from the robot or the dairy shed back to the paddock. Cows traffic to and from the dairy voluntary. Having said this, some farmers are operating the system either all year round or during certain times of the year in a batch mode. So they bring batches of cows to the robot. The robot is able to cope with that, but most of the farm systems here and overseas operating in a voluntary way. So they move around the system based on incentives. What does that mean? So traditionally at the beginning we thought that the pressure in the udder was the incentive that made the cows traffic from the paddock to the dairy, but now we very well know that that is not an incentive to make the cows traffic. What are some incentives that farmers use? Feed, resting and loafing. So for example, in coral system or barns, indoor systems use resting and loafing because they can differentiate between both. Water or shade. But feed is the number one incentive to be able to manipulate or manage cow traffic in a system. That is the most effective way of managing cow traffic around the system, and that guarantees the best traffic. So access to pasture, access to concentrates in the dairy, or access to ration make cows move around the system. The third concept that I want to introduce is that these systems are distributed. As cow traffic occurs voluntary, There is no more milking sessions. Milkings occur distributed over a 24/7 period. What does that mean is that milkings occur all day long except when the system is washing. But there's a difference between the indoor system and the pasture-based system. If you look at the left of your screen, you will see the milking distribution graph for an indoor system. On the x-axis or the horizontal graphic axis are the hours of the day, and on the vertical axis or the y-axis are the average milkings per machine per hour. So indoor systems have a flat, almost flat distribution of milking events across the day, whereas pasture-based systems that are shown on the right tend to have this dip of milkings in early hours of the day. The main difference for that is that pasture-based systems that rely on feed being the main incentives as indoor system, feeding and loafing occurs in the same place, and that is the pasture. So at that time of the day, cows are resting or sleeping, and they do not move to the dairy. So the great challenge for pasture-based systems is being able to fill this gap in early hours of the day, because that will allow for the cows that are currently in the system to milk more frequently, or will it also allow to put more cows in the system if we're able to fit more milkings in those early hours of the day. But the main concept that I want you to remember is that as milkings occur in a voluntary way, cows choose at what time of the day they want to get milked, and that translates into a distributed pattern of milkings across the day. So what can't an AMS do? Basically, as I said before, an AMS does all the milking related tasks, but there are a lot of other tasks that still have to be conducted by the farmer. So the farmer still has to allocate pasture, measure pasture, and allocate pasture to their herds. The farmer still has to fetch calves from the calving pen and take them to the calf shed and manage those calves. They have to fetch a proportion of milk of cows that do not voluntarily move through the system. So it varies between farms, but I would say between 5 and 10% of cows do require fetching, and those tend to be the late lactation cows or the cows that are in heat or are about to get in heat, or if there was any problem in the allocation of feed. Farmers still have to change filters, farmers still have to hose the yards, farmers still have to allocate supplements, farmers still have to conduct herd health inspections, that is either other inspections or feed inspections. Farmers still have to replace chemicals, that is teat spray or acid or alkaline detergent for the washing of the system. They still have to inseminate the cows. They still have to do some tractor work here and there. So what it basically does, it frees labor from the milking related task, but there is still a lot of tasks that have to be conducted on the farm. So this provides the flexibility, not having to be tied up twice a day at least on average for the milking sessions, early start and early finishing. It removes the labor from those tasks, but farming is still part of the whole operation. Farmers still have tasks to do. They just don't have to milk the cows. So what are the main advantages of AMS? As I said before, AMS provides a huge flexibility around labor tasks. It is less physical, so people are not relying on putting cups any longer. It provides a big dose of improved lifestyle because it doesn't involve early start and late finishes, and it provides some flexibility for people involved. Farmers are able to milk more cows with less full-time employees. So Future Dairy conducted labor case studies 2 years ago, and they monitored 5 farms around Australia, and they saw that the average number of cows milked per full-time equivalent in an AMS ranged between 100 and 273, whereas the average of cows milked in a conventional dairy in those regions was between 99 and 137. So there was an improvement between 1% and 99% of cows that could be milked per full-time equivalent. What we tend to see is that farmers do not work less hours, but they're able to manage more cows or they're able to do other works on the farm or pay attention to other tasks that before they couldn't. So they become better pasture managers, better health managers, better herd people. Then the system provides a lot of data, but the key challenge is translating that data into useful information. This system provides the option for higher milking frequency, and higher milking frequency is usually associated with a positive impact on milk yield. But the achievements or the improvements in milk yield will vary between farms. The probably two other great benefits from the cow point of view is the consistency and the routine. So it doesn't matter if it rains, if it's a weekend, if there's a footy game or whatever, the robots always do every task in the same consistent way. What are the main challenges of AMS on the other hand? It involves a steep learning curve for farmers. So it requires a new set of skills that farmers can learn, but it involves learning to manage these incentives and this cow traffic in the system. Then not every farm is suitable for AMS, so the size, the shape, and the distance that cows have to walk may affect the way we implement or may change the way we implement this technology. Then there is a proportion of cows that are not suited for AMS. So some because of temperament, some because of other conformation. What we tend to see is the farmers thought that they would have to discard around 10 to 12% of the cows that they were milking in the conventional dairy, but when they adopt AMS, we always recommend put the whole herd through the robots and let the cows and the robots decide which ones are suitable. And we tend to see that around 3 to 4% of cows don't adapt. So it's much lower than what farmers expect. Then I always say that cows learn much quicker than people. Within, I would say, a week, cows know what they're doing. It takes a bit longer for people to adapt to this new way of farming. It requires some technical skills to manage that technology. That is not to scare people, but yes, they're handling a new piece of technology and they have to be prepared to manage and see and conduct some other tasks that before they did not have to do. It is also obviously very important at the moment of deciding to implement this technology to rely on an equipment provider that can provide adequate technical service and support. Then it requires the farmer to be on call 24/7 because milkings occur 24/7. So alarms may call at any time of the day. Farmers that are managing good the system have very few calls, but the possibility always exists. And also the associated cost. So there is a cost on investing in the equipment, but also a cost in maintaining and repairing the equipment, and you will be able to discuss that with equipment providers. But there's also probably a higher energy cost in running the system because this is running 24/7. So we conducted some energy audits early this year, and we saw that the range in kilowatts hour per 1,000 liters of milk ranged between 53 and 132. So there is a wide range out there, and that will depend on the equipment installed. For those farmers considering an AMS, I would considering doing some financial analysis or using some kind of partial budget calculator. This was what was developed by Future Dairy. It's available online on the website, and you will be able to consider different factors that will change with AMS and how different factors could impact economically the whole decision. So I hugely suggest you to explore this tool that is available online for free to all of you. So what type of robots are available for the Australian dairy market? On the top corner, you will see the two brands, De Laval and Lely, that offer single box robots. Those are probably the most common type of robots installed in Australia and over the world, and it's one robot arm operating one milking stall at a time. On the bottom corner, you will see GEA and Incentec robot supplied and serviced by Davies Way. Those two robots are also installed in Australia and are what we call multi-box robots. So it's one robotic arm operating in more than one stall. So the robot moves attending multiple stalls. And on the right side, you will see the De Laval robotic rotary. That is a rotary aimed for it was aimed to develop to milk larger herds, despite the fact that all the other brands can still milk larger herds. You only just need more boxes. but the cost will depend on the operations in each case. But the robotic rotary has 5 robotic arms and a 24 bales milking cows, also in a voluntary way. So what is the current status of AMS in Australia? There are 36 farms up and running, basically in every dairy region in Australia, and at least 5 farms being installed. What does that mean from the adoption point of view? There is basically 144 robots installed in Australia, milking over 10,000 cows, producing 56 million litres of milk per year. The first robot in Australia was installed in 2001, so it is also not new for Australia. What type of systems are installed in Australia? So basically we have robots operating in different systems. Let's see if I can change slide. Basically we have robots operating in indoor systems, coral-based systems, and pasture-based systems. But pasture-based systems are still the largest proportion. So 83% of the farms are being operating in pasture-based conditions. So what is achievable under AMS? The New South Wales Department of Primary Industry and me under my role started what we call the AMS KPI project, that we are monitoring 9 AMS farms around Australia on a monthly basis over 12 months. And this provides a huge amount of information of what is achievable from production and performance point of view. I suggest you to go online to New South Wales DPI's website, and I can provide the link if needed, but that provides a track. We've already had July, August, and September reports produced to be able to say what is achievable from the production and performance point of view. Furthermore, from the pasture utilization point of view, there was research conducted at Future Dairy that monitored an AMS and a CMS farm over a bit over a year, and we saw that the pasture utilization levels were exactly the same. So both systems under research conditions were able to achieve 13.5 tons of dry matter per hectare of pasture utilization. So this means that pasture utilization is not affected when we incorporate robots. So are you thinking about AMS, or what do I suggest to anyone thinking about AMS? Basically, take your time and do your homework. This is not an easy decision, and it involves a lot of steps. So farmers need to be able to be doing it for the right reasons. Farmers must have clear expectations of what they can achieve with this system. If you have the wrong expectations, the technology will never deliver to your expectations. So the expectations have to be clear. I also suggest farmers considering this technology to spend time with farmers doing the job. Visit farms. Then you will be able to learn firsthand what the technology can and cannot do, and what are the benefits that those farmers are adopting. Talk to all the equipment providers, and I showed you the equipment providers up there, because they will give you a whole range of opportunities that may be able to suit your farming operation. Then run an economic analysis on the alternatives. Know your running costs today. So for example, Dairy Base is an initiative by Dairy Australia that analyzes the financial performance of a farm. It is an excellent opportunity and tool for you to analyze the farm performance before going to AMS, and then you will be able to compare what the change is. And currently I'm involved in a project trying to analyze hopefully 10 farms using Dairy Base. Then spend time planning. The farmers that I see that have achieved the best results are those that have spent more time planning the pre-installation, the installation, the commissioning, and the first weeks of the system. And also feel free to contact me if you have any question. My role is that, and I'm always available to discuss this. Where can you go for more information? Basically, I've produced together with Dairy Australia 2 tech notes that are available on Dairy Australia's website on the animal performance and technology section. The Future Dairy project has a website that has a lot of resources, and I also coordinate the New South Wales DPI Dairy Facebook page, so you can look for me there, and I provide a lot of links and information. And also I manage and coordinate the New South Wales DPI Dairy Automatic Milking Systems newsletter, and that goes out 4 times a year. We've already had 2 editions. The next edition is going out hopefully in November, and that provides a huge amount of information that is useful for anyone interested or considering this technology. So as a conclusion, and reaching the 12:30 mark, AMS is not new. It's been around in the world since 1992 and in Australia for 2001, and 36 farmers are doing the job. AMS should be an option for anyone considering a new dairy. It's a decision that you make now that will last for the next 10, 15 years. So consider robots as an option. That does not mean that robots are suitable for everyone, but I consider that everyone should consider robots as a suitable option moving into the future. AMS, as I showed you, can work in different systems. So it's a matter of analyzing your farm system and can we operate robots under those conditions. We have a very good understanding of what is achievable, and those 9 farms that we monitor will provide a further indication of the commercial conditions, but very good results are being achieved. In those farms are milking on average in the 3 months that we've monitored, between 172 and 200 cows, and they're producing somewhere between 24 and 28 liters of milk, being milked 2.5 times a day, consuming almost 7 kilograms of concentrate in the dairy. So we have a good indication of what is achievable. Then farmers must do the homework and spend time preparing for this new way of farming. It is exciting. It provides a good range of advantages and flexibility for lifestyle, but there are also challenges associated. So have a thought, consider it, and I'm always available if you want to have a chat to discuss about what moving into this new way of farming could involve. So with this, I would like to thank you very much for your attention. It's 12:31, so I think we've done pretty good. I'm still available if anybody wants to ask any question. You have the chat available. I've tried to answer some of the questions that were sent to me during the registration form in the Google form for those of you who had it. So any of you that would have any question, I would encourage to ask any question. Maybe there's some of you that are not available by chat, so I will make available the microphone, so I will unmute all of you if you want to ask any question. That is fine. I will only try to talk one at a time. So now I've unmuted all of you. If anybody has any particular question, I'm available here. Okay, there appear to be no questions I would like to be asked. So having said that, I would like to thank you all for joining this first webinar. I would appreciate any feedback or any comment that you would like to make by email to me. My email is Nicolas with no H .Lyons Lyons at dpi.nsw.gov.au to ask me or flick any comment or feedback about this webinar. So thank you very much for joining, and hopefully this is an initiative that we keep and maintaining to the future, because it will provide a lot of information for all of you. So for anyone that is interested in more information, please go to the New South Wales Department of Primary Industry website. Under the agricultural section, there's a livestock section and a dairy section, and there's a robotic milking system section, and there you will be able to see information on the KPI project, the newsletter, and some podcasts and YouTube videos that we've conducted. Thank you very much for joining, and hope to see you in the future.